Hello everybody. So just recently a colleague of mine, Vincent Mechler, he implemented LoRa for FutureSDR, and this code is now merged, and that means in the examples we got a new directory, LoRa, and this implementation is based on LoRa SDR, which I think is the most popular software-defined radio implementation and also the best one DSP-wise. And yeah, we extended a bit in the context of this work, so as you will see. So the example comes with several demo applications, so loopback, different receivers, different transmitters. I just want to give you a brief overview of what you can do with this implementation. So I want to start with the loopback example. And obviously here we are just connecting the transmitter to the receiver, and you can see that basically it's decoding its own frames. You get some console output and you get the decoded data here as a vector. And I think this is hello world with a sequence number or something like this. And but the more interesting part I think is that it also is a good example to demonstrate how you can interface our implementation. So basically our decoder outputs just the raw payload of the frame, and it has a second output that wraps all this the frame in a RF tab and LoRa tab header, and this is very helpful if you want to feed this to Wireshark, T-Shark, or that are then able to parse your frame. Okay, so and in this case we just output as an example, we just output this over UDP. So the payload is on port, we send it to port 55555, and the RF tab output is 55556. And that means if we now run this again and open another terminal and listen to port 55555, then we receive the messages. So hello world with a sequence counter and 2 extra bytes, which is the CRC. So I think this is very easy to interface with other Python programs, for example, or anyway. So it's very easy to just read from a UDP socket. So the second thing you can do is open Wireshark and the loopback interface. And here when we filter for RF tab and ICMP, we just see the LoRa tab frames. And as you can see, it's the RF tab protocol that wraps a LoRa tab LoRa frame with some metadata. I think this metadata we don't really fill out properly. And then here you got the data payload, which you can see is still this hello world with the sequence number. So you also get it in Wireshark if this is helpful for you. So with these two ways, I think it's rather straightforward to interface the implementation. Okay, so let's get to the more fun part where we do some over-the-air stuff. So here I have a LilyGo T-Beam node that is running the Meshtastic firmware, and Meshtastic is a project that is doing like encrypted chat messages over a mesh network, so completely infrastructureless multi-hop over LoRa. And so this is what we want to use or abuse for these our other demos. So we still have a very simple LoRa receiver, and all these examples use the clap Rust library, which gives you all these nice documentation for what you have to put in to make it work. And in this case, I configured this T-Beam mode to send LoRa frames. And basically I abuse the firmware a bit, so not using one of the default presets, but hard coding some LoRa physical layer configuration. So setting the bandwidth to 125 kilohertz. So this is wrong. Spreading factor of 9, coding rate 7, and we sent out at 868.5 megahertz. And if you look at the EU frequency plan, then you can see that this is uplink channel 3. Okay, so we'll have another look at Meshtastic later, but for the time being, we just kind of misuse it to send LoRa frames that we want to show that our receiver is working. So we can just 868.5 configure it. Spreading factor was 9, bandwidth was 125 if we now start this, so I also have a user P B200 mini connected. So now if we just send some message here, it will send LoRa frames. And what did I? Oh, 868 point. Now it should be the correct channel. Okay, now it's receiving the frame. But yeah, so since this is just a plain LoRa decoder, it's getting the data, it's putting it out in the same way that as we have already seen. Okay, so this basically you could now forward this with UDP similar to loop backflow graph and do your stuff. But what I also wanted to show is the other receiver, because this example now is basically what a LoRa node is doing. So it's using one channel, one bandwidth, one spreading factor, and can just receive frames there. But a LoRa gateway can listen to all uplink channels, all spreading factors in parallel. So this is what we did for this RX all channels EU example. And here we basically use a polyphase channelizer to first split out all the uplink channels, and then for each channel we then have try the different spreading factors. So in total we have 48 combinations of frequency and spreading factor, and can decode all of them in parallel. So this is what the this example is doing. So basically that means if I now enter a message, we can also receive it, which is not the interesting part, but it basically means we could now use any spreading factor on any uplink channel and we would receive all of them. And so it is now really working like a LoRa gateway, and we can have a look at the CPU load that it's causing, and you can see it's here the window manager and OBS, or the recording software, is even above our decoder. We tested it on Raspberry Pi. It also was running in real time, so it's basically not too heavy. And so that means we now have kind of a LoRa gateway, and we're thinking about, okay, so our SDR, we wanted to really kind of like could we do like a drop-in replacement for a LoRa gateway? So we were looking into the protocol that the LoRa gateway talks to the LoRaWAN network, and fortunately there's also a Rust implementation for this. So SAMTich UDP, it's implementing the protocol, and we basically just added some additional block that's taking the decoded payload, wraps it into this protocol format with metadata, and forwards it. And we can now go, so I have this project downloaded. We can run the example, so the example server that comes with it, so unmodified completely. And if we now run our LoRa gateway again, we can specify some server where it should forward the received packets. So that means we just do localhost, and it seems to use this port here by default, so we can run it. If we start now our gateway, we can already see, or it even received something already, that a new client is connected, and let's send some more frames. So we get now some more frames, and here you can see that it's attaching the correct metadata, so the spreading factor, the bandwidth, the coding rate is exactly what we configured in this Meshtastic interface, and here in this case all the metadata should be fine. Also it's annotating the SNR, I think, and yeah, a lot of stuff. You can have a look if you're interested. So in that way it really acts like a LoRa gateway. Okay. So that was for the normal LoRa stuff, and you might have already seen it. There are some more examples that are specific to Meshtastic. So let's have a look. RX Meshtastic. It's already starting. Let's have a look what we can configure. So in this case, it's basically tuned to Meshtastic, and here has a configuration for this Meshtastic presets that basically everybody's using. So that means we have to reconfigure the node to use one of the presets, and I think most of the networks seem to use this long fast mode. If we now save it, it will write the configuration to the node, and now it's rebooting the node, and then the LoRa modem gets reconfigured to this physical layer parameters. Okay, so now we have long fast configured. In this case, it's, I think here, long fast EU, and anything else can start like this. Maybe move over there. So now if we send something, we can see it received it. It even decoded it. So there's the message, and here we can we can see what we wrote into this channel, and it's just retransmitting this from time to time since it didn't get an acknowledgement. So here's another transmission of it, and we can even see some other messages that the node sends out periodically. So node infos. It will also send telemetry data and position, so telemetry app, and from time to time also the GPS position of the node and stuff like this. So we can see everything gets sent out there. And maybe you wonder why can we decode it? Shouldn't it be encrypted? And the thing is, so with Meshtastic, you can configure different channels, and this is the primary channel or the default channel, and it uses a default key. So this is well known, everybody can read it, there's no security. But we can add more channels. For example, I have a BBL channel, and this one is encrypted. It uses here a 28-bit key. So that means if I write something to the BBL channel, and should receive a frame, but we shouldn't be able to read the payload. So now we see there was a mesh packet, but we don't know what we wrote. But we support this also here. So there's this channels command line argument where you can put the channel. So in this case, BBL : and then we copy the key. So this base 64 encoded 128-bit key. Just put it here. And now if we write in this BBL channel, hopefully we should be able to read it. BBL works. Yep. So now we can decode it. And LaLa is another channel that we still don't have the key configured. It's in this case a 256-bit key. Also support this. So we can add LaLa : this key, and now if we write something in LaLa, also working. Yeah, LaLa also working. So we already got the message, and BBL works as well. So you can configure multiple channels that you want to listen to. Okay, so that was the Meshtastic part, or the let's say simple Meshtastic receiver. But we got more. There's the Meshtastic all channels application that we have. And if we look at these command line flags, you just tell it the region. So you just tell it, oh, we're in the EU. And then it knows, okay, it knows all, I don't know, 8 presets or whatever are defined by Meshtastic. It will try to decode all of them in parallel. So we can just start this. And what I didn't show you for the gateway, it's a bit funny, so you can see how the flow graph looks. So in this case, it's just the Meshtastic flow graph, and there you have an SDR. And then for the 3 different frequency that it's using, it has a frequency escalating filter. And then for each of the frequencies, it has different decoder configurations. So it is independent decoder chains. And then everything is reported to this one node, which is then decoding the Meshtastic stuff. So this is the kind of multi-channel version of it. Then just for fun, let's also look at the all channels EU, which is even bigger than this. So if we look now, Yeah, we have the SDR, a polyphase channelizer, the 8 uplink channels. How many were? Yeah, 8 uplink channels, and each uplink channel is one of the 6 spreading factors. So we have 6 independent decoding chains, but this is still working pretty fine. Okay, so back to Meshtastic. We have this Meshtastic all channels, which I think it's not so interesting. We can just make sure it works. We say, okay, we are in the EU. Now it should try to decode all configurations of the EU. So if we here now we didn't specify other channels, so let's go for the default one. It's working, message ASDF, but the cool thing here now is that we can reconfigure the LoRa, use a different presets, let's say medium fast, and store it. And now if it reboots, oh, I could have let it run. Okay, few more seconds, then it should be up again. Yeah, no, I think. So if we now send something up, so we can receive it even though it's using now a different physical layer configuration. So we're just decoding all of them in parallel. So yeah, that's it for the Meshtastic. And then the final one that I wanted to show is we have a normal LoRa transmitter, but then there's no easy way to show it now, because if you just don't send Meshtastic messages, they won't end up in Meshtastic. So let's only look at the TX Meshtastic and have a look what it allows. So obviously we also can have to set a configuration. And what did we know? Medium fast EU, I think, was the last setting we used. And yeah, now we have to obviously just configure one channel. So let's say, well, why not use the BBL one? So we have a name, BBL, and we have a key. And now we can start it. Test 1 2 3, and you can see, okay, test 1 2 3. Our message pops up into this channel, so it's the BBL channel. So it's ending up here. So here's nothing, Lala is nothing. It's ending up in this BBL channel. So another test, and yeah, so channels end up in Meshtastic. Okay, yeah, so that is everything I wanted to show you now. So if you have any other ideas, anything you want to do with this implementation, anything you would like to see, let us know. And also if there are any issues. So yeah, hope you have fun with this LoRa implementation. Bye-bye.